So a system of linear inequalities, similar to a system of equations, is two or more. We'll write this down, two or more linear inequalities that are graphed together. So basically the same thing as a linear equation. When we graph linear equations, we graph both of them together and we figured out where the lines crossed, and that was our solution. However, today our solution is going to be a little bit different because it's not necessarily a point where the two lines cross. It's an area where the two shaded regions overlap. So we're going to say the solution is the overlapping region of points. So the overlapping region of points that satisfies both inequalities. So basically, we're just doing what we did yesterday, except we have two inequalities graphed on the same line, and wherever those two inequalities overlap in terms of the shading, that will be our answer. So that's everything in terms of note-taking to get set up today. We're going to look at what we saw yesterday and use the rules that we looked at yesterday in order to make these graphs work. So you'll see pretty much the same thing we saw yesterday, except there will be an additional inequality. Sometimes we'll have to get y by itself. Sometimes we won't, just like with equations. So I'll give you a little bit of time to write that down, and then we will get started with graphing, and that's what we're going to be spending our time on today. Region. Overlapping region. Yeah. All right. So we're just going to be dealing with two inequalities. I know it says two or more. We wrote two or more for equations as well, but we only ever use two. Same thing with our inequalities. And then the solution will be where those two areas overlap. So let's go ahead and give this first one a try. We have y is greater than negative x minus 1, and we have y is less than x minus 5. So first thing I'm going to do with these is they have y by themselves already, so we don't have to move anything around to get y by itself. But I'm going to put a 1 with this x, and I'm going to put a 1 with that x, just so we know what the slopes of those lines are. And I'm going to scoot this down so we can actually see what's going on. All right. So I'm going to put a 1 in front of each of those x's, and then I want to reference what we talked about yesterday, because this is pretty much all we did yesterday, and that is once we got y by itself, we made some decisions on the type of line and where we shade. So if you were gone yesterday, if you go to Google Classroom, the notes are all there if you want to get those filled out, which would be a good idea because we're basically adding on to what we learned yesterday. So if you were absent yesterday, you'll definitely need to get those notes filled in. But very quickly, you got to get the y by itself, just like we did with equations. And then we made some decisions. If it was a less than or equal to or greater than or equal to, so if we had a line underneath our inequality symbol, then we just drew a solid line like we did with equations. If it was just a greater than or just a less than, then we made a dotted or a dashed line on the graph to indicate that that line is not part of the solution. So with both of these on this one, on this first problem, both of those inequalities are just greater than or just less than, which means that both of the lines are going to be dotted lines. So next to this one here, I'm going to write dotted. That'll be a dotted line. And the bottom one will also be dotted. And so yesterday we just put some little notes in there about what type of a line we were looking at. And then we said that if it was a greater than or equal to, then you would shade above the line, because greater than means bigger, and so bigger is usually above, and that's the case here too. So this first one here says y is greater than, so we will shade above. So the first inequality, dotted line, shade above. Second one says less than, so that one will be shaded below. It's a dotted line, but we're shading below that one. So we have all of our information here that we need in order to get these on our graph. Both dotted lines, the first one we're shading above, the second one we're shading below. And when we do this, I'm going to give you kind of some pointers on how to make it easier on yourself to see where these things overlap. And I'll show you in just a second. So let's get our first line graphed on here, our first inequality graph. And it says negative 1x minus 1. So this is already has y by itself. So we start at the y-intercept, which is negative 1. Right there. And then from that point, we have a slope of negative 1, which means down 1 over 1. And so this one just goes down 1 over 1 the whole way through. And we can line up our ruler, and we're going to make our dotted line, because remember, we're using a dotted line this time. So dotted line all the way through, or dashed line if you want to go with a dashed line, that's fine. I usually do dashes. And this one, we are shading above that line. So when we shade, I would highly recommend that you choose a direction for your shading. So what I mean by that is, instead of just shading in the entire thing, what I'm going to do above this line is I'm going to do vertical lines. I'm going to do vertical lines above this for my shading. I'm not going to fill in every inch of what's happening up there. The vertical lines are going to be really helpful when we do the other shading, because we'll be able to see much more clearly where that overlap actually is. So the next one, it says that we have y is less than 1x minus 5. Now we could put the other dotted line on here first, that's fine, before we shade it. It doesn't really matter the order of everything that you do. I'm just gonna kind of build it this way. This time I might change it up for number 2 and do it a little bit differently. If the shading makes it difficult for you to see where to put points, then wait to shade, basically. So we're gonna start at negative 5. So there's 1, 2, 3, 4, there's negative 5. And then we have a slope of 1 this time. So that's up 1 over 1 instead of down 1 over 1 like the last one. So up 1 over 1. And we can see it's a little bit more challenging to see where these points go. So if you prefer to wait to shade, you're welcome to do that. And then we've got our dotted line that goes through all those. And we are shading below that one. Now, in order to make it easier to see where the overlap happens, underneath here, I'm not going to shade vertically. I'm going to make horizontal lines. And the horizontal lines are going to make it really clear where that overlap happens. So basically, where we have a checker pattern is our answer. So where those two lines cross over, that's going to be our solution. And if you want to darken up the area where those two things cross over, which would be this little triangle on the right side. That's where we've got the vertical and the horizontal lines kind of crossing over. So this part here, just going to darken that up a little bit. This is our solution in there. That's where we have that checker pattern. So usually what that means is, and I say usually because it's most of the time it turns out this way, when you have two lines that cross, you're basically going to have a triangular area where the answer is. So that triangular area is our answer for problem number 1. Let's try number 2. Number 2, we've got our first line up here. And y is already by itself. Same with the second one. So here we go. We got to make some decisions now. Are we going to have a solid or a dotted line with the first one? Morning. So we'll do the same thing yesterday. 1 for solid, 2 for dotted on that first line on problem number 2. I see 2, dotted line. Yep, because it's just less than. So this first line is dotted. Okay. And then it says less than. So are we shading above or are we shading below the first line? Shading below. Good, because it's less than. So dotted and below for that first line right there. Now we have to make the same 2 decisions for that next line as well. The y is greater than or equal to negative x plus 4. I'm going to put a 1 in front of that x, so negative 1x plus 4. And is this one going to be 1 for solid, 2 for dotted? Solid or dotted? Solid. Good. So solid line because we have the line underneath the inequality. Solid. And then greater than, above or below? Above. Good. So we have our information in terms of how we're going to graph these on here. This time I'm going to graph both lines first. And then we'll do the shading after that. So the first line says y is less than 1/3 x plus 7. So we start at the y-intercept up at 7. Right there. And then it's up 1 over 3. We got 1/3. Up 1 over 3. Right there. And just to get one more point, I'm going to go down 1 and back 3, reverse the order of both the rise and the run, just to get a 3rd point. And then we can put our dotted line right there. So this is going to be a dotted line. And we'll get to the shading in a minute or so. I'll graph both lines first this time. So here we go. There's our dotted line. And our second equation, we're starting at positive 4. So plus 4 for the y-intercept. And then we have a slope of negative 1. So that's down 1 over 1. So we'll go down 1 over 1, and we'll just follow that pattern all the way down, directly through the corner of all those. This time, though, we're looking at a solid line. So we have a dotted line and a solid line intersecting. Now, you can shade every part of every area that you need to for both lines. Or if you know where that overlapping is going to happen, you can shade just the part where it overlaps. What I mean by that is, if we're shading below the dotted line, this one here, and above the solid line, the area where both of those things will overlap is right here. That's this whole part here. So you don't have to shade everything on your graph. If you know where these are going to overlap, you can just shade in the part where they overlap, because it's below the dotted line and it's above the solid line. And so if it's both of those things at the same time, it'll have to be this kind of right-hand side of that triangular piece over here. This is how I usually do it. I usually try to figure out where are those overlappings going to happen in the first place, and then I'm only shading in that triangular portion of the graph where it happens, because it's less busy visually if you can figure out where it's going to be. But if it helps to do the horizontal and the vertical and see where those two things overlap and make that check pattern, you're welcome to do that as well. So I'm giving you some options on how you might want to make that happen. All right. Let's go ahead and move on to a few more of these. So problem number 3. What kind of an issue do we run into on problem number 3? Somebody tell me about that. Yeah, on the first equation, y is not yet by itself. On the second equation, it is, so we're good there. But the first equation needs to be adjusted. So down here, I'm going to write 1x minus 4y is less than or equal to 24. Now, yesterday we did this a lot. So if you were gone yesterday, we did a lot of converting inequalities from whatever form it was into slope-intercept. So what's the first thing that has to happen on this equation to get y by itself? Yeah. Yep, get rid of the 1x. And so we're going to subtract 1x from both sides. Good. Yeah, you're basically moving it. Yep, you're moving it from the left side over to the right side by taking it away. And so that gives us negative 4y. So that's still a negative. Negative 4y is less than or equal to negative 1x plus 24. All right. Now we've got one more thing to do to get y all by itself. What is it? What do we have to do to get y by itself? Yep, we're going to divide everything by negative 4. Now, again, if you were gone yesterday, we did a quick review on what happens if you divide by a negative with inequality. So I'm going to do another quick review on that here because there were some people who were gone. So you don't need to write this down, but we learned back in the first trimester that if you have something like this, let's say we got negative 2x is less than 12. And when you were solving these back in trimester 1, we solve these just like we would any normal equation, divide by negative 2 on both sides to get x by itself. But because it's an inequality, what do we have to do with this symbol if we divide or multiply both sides by a negative? Everybody, we did this yesterday too, but if you were gone, if you remember, you have to flip that symbol around. Only if you divide or multiply by a negative number, though. If you multiply or divide by a positive number, you keep it exactly the same, but because we're dividing here by a negative, we'd have to switch it around. And so we'd say x is greater than negative 6. So if you have to multiply or divide both sides by a negative, the direction of the inequality switches the direction that it was before. So on this problem here, number 3, we have to do that because we're dividing everything by a negative 4. So that's going to be y is now greater than or equal to instead of less than or equal to. And then negative 1 divided by negative 4, 2 negatives divided equal positive, so 1 over 4x. And 24 divided by negative 4 is negative 6, so minus 6. So now we've got both inequalities with y all by itself. And now we have to make our two decisions about what these lines are going to look like. Now, the first line here that we just adjusted, we have a line underneath the inequality symbol. So 1 for solid, 2 for dotted. We go in solid or dotted on this one? See 1s. Yep, solid. Good. So solid, greater than, above or below? Above. So solid, above. Our other line. What are our two decisions on here? What are we going to do? What type of a line? Solid, yep. And below, yep. Less than means below. So solid line, shade below. So both solid lines this time. Shading above one of them, shading below another one. So we'll go ahead and graph our two lines. Let's just graph this one up here first. It doesn't really matter which one we do first. So both of these would be solid lines, so we don't have to worry about doing our dashes. So starting at positive 1, that's our y-intercept. And then from that point, we have a slope of 2. So that's up 2 over 1, up 2 over 1. I'm being quick with the graphing on this because we've graphed so much already that I'm not going to spend too much time reviewing the graphing. So there's our first line there. Now we're going to end up shading below that line. And then the other one is 1/4 x minus 6. So we're going to start at negative 6. Right down here. And then we have a slope of 1/4. So up 1 over 4, up 1 over 4. And that's also a solid line. And on that one, we are shading above the bottom line and below the top line. So if we're shading underneath the top line and above the bottom line, that's going to be the area kind of in between over here. That's that portion of the graph right there. So every point that is either on these lines, because they're solid lines, so points on the lines could be answers, or all the points in between them, and going on forever as well. We can't show everything because the graph, we couldn't make the graph big enough to do that, but everything in between here would be a solution that works with both of those inequalities at the same time. All right, we're going to do one more from the first page, and then we're going to take a look at page 2. So we're going to do number 4. And then after that, we'll move on and do a few from the second page. So here we go. Problem number 4, the first equation, or first inequality rather. Our first inequality is just a number with, just an x with a number across from it. So there's nothing to do there in terms of simplifying. We saw a couple like that yesterday. We'll talk about this one again. The second equation, keep saying equation, the second inequality, we do have to get y by itself. So getting y by itself on that second inequality on number 4, we have to subtract 3x from both sides first. So minus 3x minus 3x. And then that'll give us 2y is less than or equal to negative 3x minus 2. That's our first step. Second step, we have to get rid of the 2, so we divide everything by 2. And this time we're dividing by a regular 2, not a negative 2. And because we're not dividing by a negative this time, we will not be flipping this symbol around. If we divided by a negative 2, we would, but we're dividing by 2, which means it's going to stay as less than or equal to. And then our slope, our fraction, negative 3 over 2x, and then negative 2 divided by 2 would be minus 1. Those are our two inequalities. The x is less than negative 4 and y is less than or equal to negative 3 over 2x minus 1. Let's just go ahead and figure out this second line first. That's going to be a solid line because of the line underneath the inequality. So solid, and it says less than, so we're going to be shading below that line. Our first line, what type of a line is this going to be? X is less than negative 4. What type of a line is that? We saw it yesterday a couple times. Yeah, I see a couple of people doing this. Vertical, yep. So it's a vertical line for x equals, or x, keep saying equals, less than. X is less than negative 4. What type of a line is that going to end up being? I mean, we said vertical, but are we going with dotted or solid or dotted now? So solid for 1, dotted for 2. So now we got to make those decisions. 2, yep, dotted line. And then above or below. And again, above and below work a little bit differently for vertical, but it says less than, so we're shading below. And again, we'll talk about below in just a second for that. So let's go ahead and get these on our graph. That first one, vertical line at x equals negative 4. So instead of putting a point on the x-axis or y-axis, we have to put a point on the x-axis. Okay? Correct. Going sideways is not necessarily above or below in the traditional sense of above and below, because we think of up and down for that. But there's still a positive side and a negative side, right? On the x-axis. Yes, below means negative, above means positive. So below on our x-axis means to the negative side on the x-axis, which would be to the left. So below with vertical means left. And yesterday when we saw this on our notes, we made a quick note that above on a vertical line means to the right. So we put that note in yesterday with our vertical line for above. Above means to the right because you're going in the positive direction on the x-axis for above and to the negative direction on the x-axis for below. So above and below with vertical doesn't mean up and down, it means left or right. And so we'd shade on the left side of that. All right, now I'm going to go ahead and get the other line on here first before I do any shading. And this one's going to be starting at negative 1. It'll be a solid line. We're going down 3 and then over 2. All right. Morning. Thank you. We're going down 3 and over 2, and so we've got our line here. We're going with a solid line this time. Straight through there. And this one is also being shaded below, but literally below on this one. And so if we're going to the left of the vertical line and underneath the diagonal line, the area of the graph that we'll end up shading in, or that we will have the crossover on, where both of them will be shaded at the same time, is going to be this part right here. So to the left of the vertical line and underneath the diagonal line at the same time is kind of that column piece right over here on the left. And so that's what this one's going to look like for number 4. All right. Any questions so far? Very similar to what we saw yesterday, but we just have to make decisions on figuring out where that overlap is going to be, where those 2 different areas of shading happen. All right, let's skip ahead a few and we will take a look at, I think just 2 more of these. We'll just do 2 more and then go from there. So 2 more of the ones of the graphing ones, and then we are going to do the word problem. So always got to do the word problem. So we'll look at number 8 and number 9. And then the application at the end. So here we go. Number 8. The first equation, we need to make an adjustment. The second equation is good to go. It's a y is less than or equal to, which means that's a horizontal line for that y is and just a number. However, for that first inequality, we do need to make an adjustment. So this says 8y is greater than negative 10x plus 24. Now the x and the y are already on opposite sides of the inequality, which is a good thing, but the y value still has a number next to it. So we have to divide everything by 8 in order to get y by itself. So we divide by 8 all the way across. And that'll be y is greater than, because we're not dividing by a negative, so we don't flip the symbol around. Negative 10 over 8 reduces to negative 5 over 4. Those are each divisible by 2. So negative 5 over 4x, and then 24 divided by 8 is 3. So plus 3. So we got y all by itself. And now we can get our decisions made about the 2 lines and the types of lines and where we're going to shade. For the y is less than or equal to 2, because it has the line underneath the inequality, this is going to be a solid line. And because it's a less than, that would be below. And this one will actually be below because that's a horizontal line. And then this line down here, greater than, and there's no line underneath the inequality. So if there's no line underneath it, that would be a dotted line. And it says greater than, so we're shading above. So those are our 2 types of lines that we're looking at. That's the shading as well. And this horizontal line will happen at positive 2. So we put a point on the y-axis at 2, and we just draw a horizontal line straight through that. And it's going to be solid. A solid line there. Horizontally across. And then the other one has a y-intercept of 3. So we're going to go up to 3, put a point. And then our slope is negative 5 over 4. So down 5 over 4. I think we got room for one more. We'll put a dotted line through those points. Just like that. So now we have to figure out, where do we end up shading? And a lot of these end up kind of in the same region because of the way that these problems set up. But if we want to do this kind of like we did on the first one, we can. So if I were to shade, again, this is the other way that you can do this. If I want to shade below the solid line, I'm going to do vertical lines underneath my solid line. Underneath that, y is less than or equal to 2. So vertical lines underneath there. And then shading above the dotted line, and I'm going to do that with horizontal lines. So above the dotted line would be up here. And then basically wherever we get that checker pattern, where you can see those two lines making the crisscross, that would be the area, that would be the answer. If you knew that this part right here, where those two different types of lines cross over, if you knew that was going to be the answer in the first place, then you can just go ahead and shade that in. You could have shaded that in the first place and just left it like that. So you don't have to fill in as much as I did here, you know, covering up as much of the graph. If you knew it was going to be that area there to begin with, just shade that part in if you want to. Or if you want to do the horizontal and the vertical, or horizontal and the vertical, and figure out where that checker pattern happens, if that helps you, do that as well. So I'll leave that up to you in terms of how you want to make that happen. All right. The last one of these here, and then we're going to take a look at our application after that. We're going to do number 9. Any questions on 8 before we look at number 9? Okay. So number 9, last one we're going to do from the numbered ones. And both of these inequalities, we need to get y by itself. First thing I'm going to do, though, because the y's are just minus y's, I'm going to put a 1 with those. So minus 1y, minus 1y. And we have to adjust both of these. I'm going to adjust the second one first because we can just do the math right underneath here. That'll kind of save us some space. So to adjust that second inequality, we'll subtract 3x first. So minus 3x minus 3x. 3x's will cancel. And that will give us negative 1y is greater than negative 3x minus 2. And so the next thing that has to happen here is we have to divide every single thing by negative 1. And the negative 1's cancel. Because we're dividing by a negative number, we have to flip around the inequality. So it's going to say y is less than instead of greater than. And negative 3 divided by negative 1 is just 3. So that'd be 3 over 1x. And then negative 2 divided by negative 1 is positive 2. So plus 2. All right. Now, I'm hoping I left myself enough room. I'm not sure I did. We'll see what happens. So now we have to adjust that first inequality. So I'm going to try to make this fit. So 3x minus 1y is less than 6. I have to write pretty small on this one. Subtract 3x from both sides. By the way, these are going to be the same 2 steps that we just took to get y by itself on that first one. So then negative 1y is less than negative 3x plus 6. And then divide everything by negative 1 again. Because we divided by a negative, we have to flip around the inequality. And so that'll be y is greater than negative 3 divided by negative 1 is 3 over 1 again. X and then minus 6. Now, go ahead and get that written down. And I want to talk about these 2 inequalities before we graph them. Get those 2 written down, and then we're going to figure out what's going on here. So what do you notice about the slopes of those 2 lines? They're the same. So what do we know about two lines if they have the same slope? They're parallel, right? Which means that they don't cross. Now, if these were equations, we would say no solution, right? Because if two lines don't cross, there's no point where they intersect, which means there would be no solution. But with inequalities, that's not necessarily the case. We have to graph them to find out if in fact there is no solution. What I mean by that is, well, I'll show you. So let's go and get these graphed here. I'm not going to write the solid or dotted or above or below this time. We'll just go ahead and graph them. This first one here, that will be a dotted line, and we're going to shade below. So dotted and below. If you want to write that down, you're welcome to do that. I'm not going to write it down on this one. So we're going to start at +2, y-intercept is 2, and then up 3 over 1, and then up 3 over 1. Just like that, make our dotted line through those points all the way down. And now our other line is going to be parallel to that one. It will also be a dotted line, but it's being shaded above it. So that would be starting at -6 and then up 3 over 1. Also a dotted line. And so those two lines are parallel. Now, depending on where we shade, we might have no solution, but we might have solutions. Now, there is no such thing as infinitely many solutions when we're talking about inequalities. Well, I guess there is, but everything is infinitely many. Like this right here, this is infinitely many solutions because an area is a collection of infinite amounts of points. So there isn't really the opposite to no solution. It's either an area that's shaded or it's no solution. There's no in between, or there's no opposites with that. So we have to figure out now, this top line here, we were shading below the top line, and the bottom line down here, we were shading above that one. So if it's below this one and above that one, that means we're shading in between the two lines, which means there are solutions. Everything in between the two lines is a solution to this inequality. So it's like a tunnel, right? We're shading in between the two lines, which means we do have solutions because there is an area of the graph where there is overlap. Now, where it would be no solution, let's say, for example, it was greater than the top one and less than the bottom one, which means we would shade on either side here, which means there's no overlap. If there's no overlap, and unfortunately, we don't have an example in our notes of that, which is a little bit annoying. I kind of wish we did. But if you come across a problem where there isn't any overlap, that means there's no solution. You wouldn't necessarily have to write no solution either. You could just show it visually. So even if there is no solution, you don't have to write no solution. I just want to make that clear. All right. So that's the last one of the regular graphing ones we're going to do. And now we're going to look at our application problem here at the end. So actually, I'll make sure you have a chance to get that shaded. Our little tunnel. And then we'll look at our word problem and we'll call it a day. And we'll call it a unit and we'll call it a trimester in terms of notes, because tomorrow we're going to start our unit review. Monday we'll finish the unit review. Tuesday is our test. And the last 2 days of the term, Wednesday and Thursday of next week, will be basically playing catch up. If you're gone for the test on Tuesday, you'll take the test on Wednesday. Or if you need to make corrections to the test for previous tests or catch up on work, those last 2 days are going to be full days for you just to get stuff done. All right. Application problem. Here we go. Sarah's pet store has more, let me start over. Sarah's pet store never has more than a combined total of 16 cats and dogs. So basically it's probably a small shop and it doesn't have room for more than 16 animals. She also never has more than 9 cats. I mean, if it were me, I'd just have dogs, but you know, Sarah can do what she wants. She never has more than 9 cats. Write a system of inequalities and graph to show the possible number of cats and dogs in her store. So we're going to do this one just sort of as a practice. You will probably see one problem on your test that is like this, but it will likely be a bonus question. So there will be a word problem system of inequalities, but because we're not doing a full lesson on word problems of systems of inequalities, that one problem on your test will be a bonus. The systems of equations word problems, though, will not be bonus questions. We spent like 2 full days earlier this week working on those. Those will be part of your test. Those will be questions that you'll need to do. We'll do one example like this here, and then if you want to try the bonus one on your test, you're welcome to do that. So we're going to write 2 inequalities here, and I'm just going to show you how to do this because I mean it's a little bit challenging because we have to talk about greater than, less than, is it equal to, could it be, you know, whatever it is. So Sarah's pet store never has more than a combined total of 16 cats and dogs. So again, just like with equations, we have to have 2 variables here, and there are 2 different things being talked about. What are those 2 things? What 2 things exist in her store? Yeah, cats and dogs. So X will be number of cats, and Y will be number of dogs. All right. And it says that she never has more than a combined total of 16 animals, which means she could have 16, right? But she could not have 17. She might have 15 or 12 or 3, up to 16, but no more than. So the total amount of cats, X, plus the total amount of dogs, Y, has to be less than or equal to 16, no more than. Up to 16, could be less than, could be 16, but can't be more than 16. That's our first inequality. Now, the second inequality is only talking about what? Or the next sentence is only talking about what? Just cats, right? She never has more than 9 cats. So the second inequality is only talking about cats, which means it's only talking about X. So maybe it's 9 cats, maybe it's 8 cats, it's never 10 or 11. So that would be X is less than or equal to 9. Those are the 2 inequalities that we're dealing with. Now this second inequality, that's a vertical line. Our first inequality, though, we have to make an adjustment to, because we have to get Y by itself. So I'm going to put a 1 in front of the X. I'm not going to put a 1 in front of the Y, though, because it's a positive Y, and we're just trying to get Y by itself. So what we need to do here is minus 1x from both sides. Because if we're going to graph it, we have to have Y by itself, and that'll be Y is less than or equal to negative 1x plus 16. So these are our 2 inequalities that we're going to graph. Our first one here says less than or equal to, so that's going to be a solid line. And it says less than, so we're going to shade below. And it's actually the same for the other one as well, solid and below. But what that means for vertical is left. Below means to the left. And we also need to kind of do a little bit of setup work with our graph over here, because this is not a traditional looking graph. Our X and our Y's don't really do a lot of intersecting. Like 0 is in the bottom left. We don't see a lot of graphs like this in this class. You probably see a lot of graphs like this in your science class. But we oftentimes use all 4 quadrants in math, whereas in science, most of the time, from what I remember, and maybe this is still true, you're going to use quadrant 1 most of the time, which is what we're doing today. So here's our x-axis right there. Here's our y-axis right here. And because we're dealing with 2 different things that are related on those axes, we should label those. So the x-axis is going to be cats. And then the y-axis will be dogs. So cats on the x-axis, dogs on the y-axis. And we'll just go ahead and graph this first one here. It says y is less than or equal to negative 1x plus 16. So we got to count up 16 on our y-axis, and I'm hoping there's enough points on here to make that happen. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, we're good. 11, 12, 13, 14, 15, 16 right there. Okay. That's interesting. It only goes up to 19. It's an odd amount of points to put on a graph or grid lines. So there's 16 up there. Our slope is -1, so that's down 1 over 1. So we're going to go down 1 over 1 all the way across the graph. And that'll be a solid line. Now I'm not going to put arrows at the ends of this graph because arrows don't really make sense on this graph. And that's because you're not going to have less than 0 animals. Arrows indicate that it continues going. There's no point in putting arrows on here because we're not going to go into the negatives in any way whatsoever with the number of animals. That doesn't make sense. The other one is going to be a vertical line at +9 on the x-axis. And it'll also be a solid line. So we'll count +9. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9 right here. And we'll do a solid vertical line straight through that point. Like that. And so it has to be less than both of those lines. So to the left of the vertical line and then underneath the diagonal line. So we're looking at this area right here. And technically speaking, we shouldn't actually shade all of this, even though we're going to. And the reason why shading it isn't necessarily the best thing to do is because shading it indicates that everything in there makes sense as an answer. That's not really the case because we're only talking about, whole numbers of dogs and cats, right? It would be kind of messed up if you've got half of a cat, right? That doesn't make sense. That would be barbaric. We don't do that. What's that? Oh man, that sounds like some weird science happening. So yeah, in a cartoon, there you go. But basically, the only ones that really make sense are the actual whole number points. So really what we should have done, but would have taken a lot of time, is actually put a dot on each of those whole number coordinates. But exactly, that's why we'll shade it. And we'll just say, you know what, people are reasonable enough to know that the amount of cats and dogs are going to be, full amounts of cats and dogs, which is how it is at shelters and things like that. So that's how we can work with those. But again, the problem on your test like that will be a bonus question, but you can reference that if you want to give it a try. So that is it. We are done.